Hi everyone, my name is Johan Discho and I'm the coach of ZEISSMED. For the past 2 months, we are working to improve the workflow efficiency for cataract treatment, or as it is in German, Gauarstar, using the OCR technology. I want to thank our dear customers, Ms. Dahlmann and Mr. Steinberg, for their presence and also for their support. That's it from my side. I hope you enjoy our great presentation.
The human eye is one of our most fascinating organs. It lets us appreciate the beauty of the world in all its glory. But you should not take it for granted. Cataract is one of the main causes of blindness worldwide. Over 50% of the people at the age of 75 have their vision affected by this disease. Luckily, there is a treatment for cataract: intraocular lenses from ZEISS. These lenses are customized for every patient. But the manual input of measurement results into the calculation tool is time-consuming, tedious, and error-prone.
Dr. Alexandra, come here. Here, please help me with this here. I have no time for this.
Here is where our app comes into play. ZEISS lets you easily scan printouts and directly upload them into the ZEISS calculation tool.
Nice.
So that doctors have more time for their patients. We make it visible.
Dr. Alexandra, wait. You have better things to do.
No, it's okay.
No, you have better things to do. Thank you.
Okay, so what you just saw is the essence of the problem we are trying to solve with our app. These machines on the left produce paper printouts that have all the measurement data of your eye, and then surgeons or sales representatives from ZEISS have to manually enter those inputs into a ZEISS calculation website, which then calculates the optimal lens for the patient. Of course, this process is very inefficient, it's tedious, and it's also error-prone. And you really do not want to have any errors happening if you put something into the eye of your patient. Sasha is now going to talk to you about what we are trying to solve this problem.
Our goal now is to help ZEISS to make their employees, their customers, the surgeons, and on top of that, even the patients more satisfied and happy by improving the workflow and the surgery results. Now, these are pretty noble goals, right? But also very generic. So how exactly are we planning to achieve this? That's where our app and our project requirements come into play. We face two main challenges in our project. The first one is the automatic scanning of the measurement data. So it is required that we scan these printouts, which is basically a piece of paper, and then automatically extract the data from them. What makes it additionally difficult is that there's not only one type of printout. There are different possible layouts based on the type of measurement equipment that is being used. The second big challenge that we have is the automatic website input. So we would like to, or the requirement is to put that data that got extracted automatically into a calculation website. This requirement is special because of a constraint. Due to the short project time span and medical regulations, it's not possible for ZEISS to offer an official API for us. So we have to make this possible anyway. Another important requirement is the research data collection. So far, it has not really been possible for ZEISS to evaluate surgery results and rate the performance of their products. But this would be crucial to improve their products even further and also ensure the well-being of the patients. A non-functional requirement that we have is an intuitive UI, so the app should be easy and fun to use. And also it should support multi-languages, because ZEISS plans to roll out the app in international markets. Now, to give you an idea on how we fulfill those requirements and explain our project architecture and structure, we will take a look at our top-level design. We have the sales rep and the surgeon who use our app on their device. The whole process starts with them taking a picture of the measurement report. We then pre-process that report on the device and we send it to our server. And that's where the actual magic happens. That's where we use optical character recognition to extract the information from the image. Now we have usable data and we store the data for the research purposes. We also automatically input the data into the calculator website. And now the website calculates the best suitable lens for our patient or a suggestion for multiple lenses out of a vast selection of possible lenses. Once we have the result, we return that back and display it on the device. We also then notify the surgeon that there is a new result available that he can validate. So if he's happy with the results, he validates it, and after that he can even immediately order the lens. Now, to illustrate our problem domain further, let's take a brief look at a simplified version of our analysis object model. Again, we start with the user. We have the sales rep and the surgeon. The surgeon is responsible for treating multiple patients, and for patients we can create measurements. Those measurements then each get a calculation result, and we can turn them into order items that are part of a bigger order that can include additional equipment that the surgeon or the hospital might need. Last but not least, we have the satisfaction report, where a patient can give feedback on how he experienced the surgery process.
Now that you know about our basic process, let's take a deeper look into our more technical aspects of this app. We cannot expect our users to be perfect photographers or to know how to hold their cell phone so that they get a nice, clean image of the printout. So we pre-process everything on the device. For this, we first have to find the actual paper printout using a series of computer vision algorithms that we use. And once we have a contour approximation of the printout, we can then adjust the angle and the skew to get a nice top-down view of the printout, which we can then send to our cloud. Here, we separate the image into different boxes so that oh, sorry, that did not work. Let's try again. Okay, perfect. We separate the image so that we have different boxes, and then we can run our OCR Tesseract tool, which recognizes the actual text out of these boxes, which we then combine to have a nice, readable data that we can then send to our calculation tool, or to the ZEISS calculation tool. I'm sure you now heard of all of this about in theory, that you want to see it in practice. So please, welcome Kira and Christian on stage.
The whole calculation I've been doing the whole time, I did it wrong. I had to redo it the whole again. Now I get why Dr. Brugge is always frustrated when he talks about this.
Oh, hello, Dr. Demo. What's wrong? Are you still working on these printouts?
Hello, Miss Klimt. Yes, and it's like really, I can really can't anymore.
Oh, I see. But then I actually have something from you. It just came in. It's a new iPhone app from ZEISS, and you can do 100 printouts a day with it. It's really amazing.
Oh, really? Show it to me.
Yes, I can actually show it to you now. So, okay. Now here we have our app, and here we have our printout. And what we just do is taking a picture of the printout, so maybe like this. And you see it automatically recognizes where in the picture the printout is. So we just click on save, and here we can see our just taken scanned data is now processing. And it's only taking some seconds, now it's done. And here you can see all the data you have in the printout already in your app without having to type it in manually. So you can check if it's correct.
It is. Everything is correct.
Cool.
Oh my God.
So then we approve that it's correct, and we can calculate our lens.
How long does it take?
Oh, just some seconds. It's really fast.
Okay. Oh.
Okay. Now here we have our data for our different lenses, and you can select which lens you want. So for the right lens, maybe this
one is right.
And what do you want for the left lens?
The second one looks good.
Okay. And now we can directly order a lens in our app, and you're done.
Wow, this is so much fun. Can I use it too?
Well, not yet. It's only available for me, for sales representatives at the moment, but it will be for surgeons very soon.
How soon is very soon?
At the end of July already.
So it's only 1 month, right?
Yes.
Wow, that size development team really are quick, aren't they?
Yes, right?
Wow.
Thank you very much. So it's more or less the current status that we have. We finished the measurement data scanning, which means that we can scan the printout, we can upload it to our cloud, we can scan the actual OCR, and we can also send this calculation results to the ZEISS website. What we still have to do is we have to be able to recognize different layouts, because those machines, depending on the version number they have, they produce different layouts, so we have to do this. We also have to do the research data collection, which means that ZEISS wants to have the different measurements after the surgery and before the surgery. So we have to do that. And we also have to do, as you heard, the surgeon perspective, which means we have to do the views and we have to do the actual verification and the notifications for the surgeons. And we also have to do the patient journey so that, that the doctor can see where the patient data changed. I'm really glad that you kept also quiet. I would like to thank you for your attention. And if our customer has any questions, we would be happy to ask them, answer them. Thank you.
First of all, thank you very much for the great presentation and also the impressive progress of the project that we could see today. My main question is related to the OCR interface. How confident are you that it's really very reliable today? And if you're not yet confident that it's 100% reliable, that we really transmit the correct data, what could we do in order to make it more reliable and test it?
So I think our current status, we're quite happy with it. What we can't give at the moment is a precise accuracy. But we have already planned that for the next sprint. So we are planning to develop a test suite where we basically run through a lot of calculations, a lot of measurements, and then see how we perform. And based on that, we can also identify where the problems are. So maybe it's always like bad lighting can cause bad results and things like this. So at the moment, under good circumstances, we already have very precise results. That means if the lighting is good and if the angle is not too weird, but as you have seen in the demo, we can handle quite a lot. So this shouldn't be a problem. But then in the future, we will even have real accuracy that we can provide. Did that answer the question? Oh, okay, perfect. Oh, you don't have your microphone anymore, okay. Good. And she was happy, perfect. Thank you very much for your attention.